No, absolutely not. Tell me what this is. So, for your whole math career, ever since you started talking about this, people have told you that's the square root sign. And that's true. Okay? There's times when we teach you stuff because that's the appropriate skill level for us to teach you stuff, right? Well, it's not exactly what it's called. It's what we use it for, right? This is actually called a radical. Okay? Radical. You already knew we were talking about radicals today, though, didn't you? How'd you know?
It's on the board.
Oh, we wrote it down, right? On our lesson plans, our student-friendly learning objective. Okay? We already wrote that down. You know we're going to work with simplifying radical expressions. So you knew at some point I was going to have to talk about what a radical was. I'm not talking about people that block freeways. I'm not talking about terrorists. Not saying that those two are the same thing either. Okay? Just saying, sometimes both of those people are called radicals, right? Okay? This is the sign in math that we call a radical. Most of the time we use it, we're using it to take a square root. And that's why we call it a square root. That's why the people that taught it to you called it a square root sign. Because that's what we do most often. Now we're more educated, our skill level is higher, so now we need to make sure that our vocabulary is correct. Fair? Okay, so today we're going to do stuff like this. The square root of 7 plus the square root of 7. Do you happen to know the square root of 7?
49.
So no, right? So if I have a square root of 7 plus a square root of 7, would it make sense that I end up with 2 square roots of 7? If I had 3 square roots of 5 plus 4 square roots of 5, would it make sense that I would have 7 square roots of 5? When I'm adding, let me do one more. 9 square roots of 11 minus 3 square roots of 11. Yeah, that's exactly right. 6 square roots of 11. Does it make sense that when I add and subtract, I wouldn't mess with the root signs at all? I said to you a minute ago, do you know what the square root of 7 is? You don't, do you? Guess what? Neither do I. We could probably figure it out kind of close. It's not something we need to know right now, though, right? Okay? What if I called this x and this x? Aren't they the same? So I could call them both x. What's x plus x? 2x, right? Now, it's not, I didn't change the x. I didn't say it's x squared. Because I said I have one x and another x. That makes 2 x's. It's the same way here. I have a square root of 7 and a square root of 7. I just get 2 square roots of 7. Okay? So this is something that you've done before, just really never in this situation. Does that make sense? Okay? So if I don't mess with the root sign, what's in the root sign, the radical, when I add or subtract, do you think I might mess with it when we're multiplying or dividing? Yes, I would. Okay? So if I say square root of 3 times the square root of 5, that's really the same thing as the square root of 3 times 5, which would be the square root of 15. Now, if I took you here and I said, here's the problem, how many of you could skip this step and go straight here? That's an easy step to skip right there, isn't it? Okay? Let me tell you why I don't want to skip it. I'll tell you in just a second. We're not ready for it yet. But I'm telling you right now we're going to write it because of what's coming up soon. Fair enough? Okay? So what about the square root of 2 divided by the square root of 8? Well, using this kind of thought process, wouldn't this be the same as the square root of 2 over 8? It would, wouldn't it? Well, isn't that the square root of 1/4? Wait a second. Do I know the square root of 1/4? Using our rules from yesterday that we talked about, isn't this and from like right here, isn't this the same as the square root of 1 over the square root of 4? Yes. Do you know the square root of 1? 1. Do you know the square root of 4? 2. So what should my answer be, you think? 1/2. That's amazing. Good job. Adding, subtracting, multiplying, dividing. Simplifying radical expressions. Yes? We also need to make sure we know how to simplify radicals. And that's where this part comes in right here. Okay? So if I ask you to simplify a radical like, oh, I'm going to throw something else in here too. Can I do that? Like this. Yeah, just like a square root, we think of what times itself equals that number. This just means a cube root. It means what times itself is 125. Now, this one's a relatively easy one to think about, but what I want to do is I want to make sure you know how to do this in the calculator. Can I do that? Okay. So, first thing we do always, turn on our calculator. Okay? With the power button, yes. It's actually the on button. It doesn't say power, but hopefully you can figure that out. Okay? We want a calculator document. And I want to make sure you know how to put the cube root of something in your calculator. Okay? Now, are we going to use our calculator a lot today? We're really not. Okay? Because never in all these up here did I say, okay, let's put 2 root 7 in the calculator and figure out what the decimal is, did I? Because we don't care. All we're doing right now is simplifying radical expressions. The only thing you may need your calculator for is some arithmetic, because I don't want you to get bogged down by the arithmetic. Fair enough? Okay? So in your calculator, I want you to push the control button, the yellow button, and the button 2 down from it. Upside down V, house top, power button, that has a lot of different names. Okay? Notice that when you press that one, not the one beside it with that's the square root, but this one, we can put in a 3. We can put in a cube root. That's not a multiplier. That's a root of 125. Now, some of you already knew that was 5, didn't you? You'd already showed me. You'd already showed me with your hands. It was 5, right? Okay, thank you for not saying it out loud. We just needed to get there first. Okay, so we know that's 5. But I guess what comes up is something like this. The cube root of 24. Well, if I'm just checking, I could say the cube root, of 24. Ugh. Not good. Am I just going to write that down? No, we're simplifying. We're not getting decimal answers, are we? Okay, we're just simplifying. So I have to think about this for a second. Now, I could have thought about it to begin with and said what times what equals 24. Well, I know 2 times 2 times 2 is 8, and I know 3 times 3 times 3 is 27. So I know it's a little bit less than 3, but it's not a nice whole number, is it? So I have to think about this for just a second. And I need to do, remember I told you we're going to use this? Now is the time. Okay? Now we're starting over here and we're going backwards to see if we can figure stuff out over here. Now I'm going to say this is really 8 times 3. Why did I choose 8 and 3 instead of choosing 6 and 4? You know the cube root of 8, don't you? That's exactly right. You know the cube root of 8. What is the cube root of 8? 2, right? So that means I could break this into this. I know the cube root of 8, don't I? You just told me you knew what it was. What is it? 2. Do we know the cube root of 3? Then we're going to leave it. This is as simplified as I can get for this problem right here. Okay? Excuse me. Got it? So I got to show you one more thing. You ready? We got to simplify that. Now, and looking at that, to me, that already looks pretty darn simplified, doesn't it? Right? But one of those things that those mathematician police that come around all the time, they do not like radicals in the denominator. And although it officially doesn't look like I have a radical in the denominator, you know, because of the rules of radicals, that this is really the same as this, isn't it? And so I do have a radical in the denominator, don't I? So I need something inside here that I know the square root of. What's a number related to 8 somehow that you know the square root of? It's going to have to be bigger than that. Bigger than 8. 16? We could use 16. How do I get from 8 to 16? I multiply it by 2. But can I multiply it by 2? First of all, I can't multiply anything by 2 without changing its value, right? What's the only thing I can multiply something by and keep its value? 1, right? I multiply it by 1. So I actually want to multiply it by this. Square root of 2 over the square root of 2, don't I? First of all, it can't just be 2, because if I said 2 times the square root of 8, I just get 2 square root of 8. I need something to go inside the radical, don't I? And the only way it'll go inside the radical is if I multiply it by another radical. Now I can multiply this together and get the square root of 16, right? What happens in the numerator? What do I get up there? Square root of 6? Do I know the square root of 6? Well, let me rephrase that. Do you know the square root of 6? No. Do I know the square root of 6? No, I don't. I don't. I can figure it out, kind of guess close-ish, right? But you could too, right? But do we know the square root of 16? Done. So I have to figure out what number in the denominator do I need, right? What if this was a cube root of like 5? I'll make it hard on myself and make it cube root of 5 over like 3 or something like that. What's related to 5 that I know the cube root of? I know the square root of 25, but I don't know the cube root of 25. What do you say? 125, right? So what would I have to multiply this by to be able to know what was in the root? The cube root of 25, right? So what do I have left in the numerator? 3 cube roots of 25, right? And what do I have in the denominator? Cube root of what? 125. Do we know the cube root of 25? No, we do not. Okay, so I have to leave that exactly as it was. Do I know the cube root of 125? Yeah, I do. It's 5. I did that on purpose, right? We chose this number on purpose so it would be something that we knew the cube root of. I can't do anything else with this at all. That's my answer. I have to warn you guys, though. You know what some people have tried to do today? Simplify this, because those are both divisible by 5. It would change the value, wouldn't it? You have to be very careful. The only time you can ever take something out of a square root or a cube root or a fourth root, the only time you can take something out of a radical is if you know that root. We can't just cancel stuff out because they're both divisible by the same thing. And you know how I feel about canceling, right? We don't cancel stuff. We simplify it to 1. We simplify it to 0. We've already had the discussion about how confusing that can get, don't we? Okay? Questions? Yes, ma'am. Why did I choose 25? Okay, can somebody help her out? Why did I choose this 25 right here? I needed something that I knew the cube root of. Something related to 5. And so, and in the event that I can't think of anything, I just 5 times 5 times 5. I know that's going to be 5, right? If I take the cube root of it. So I just multiplied it by cube root of 25. Okay? Good question. Any questions on this? We good? You may have questions as you work. That's totally fine, right? That's my job. That's what I like to do, is help you with math. Most of the time. To be fair. To be fair. Yeah, okay? So please take your time. Work through these problems. You know I have my answer key back on my desk if you want to check as you go. Ask questions as you go. Keep a positive attitude about it, though. Do one problem at a time. Today, there's been several people that have just gotten super overwhelmed by this because they've tried to do 5 or 6 problems at a time. Do one problem at a time and go on to the next problem. Okay? It does take a lot of thought, doesn't it? Once I figure it out, none of the work is hard. It takes some thought to get to the right work, right? Okay, so please stay calm. Take your time, and I'll help you when you need help. All right? Okay, go ahead and get to work. Peace.